So I'm William Trouleau, I'm from EPFL, and I'm going to present you a joint work with Azin Ashkan, Wei Kong Ding, and Brian Erickson from Technical Research. Okay, so I'm going to talk to you about user video consumption, and in particular something I think you all do, even if you don't really admit it. It's binge watching. All right, so let's first start to see how people first used to consume TV shows in the past. So in the past, you had only TV. Everyone had to watch whatever was on TV at that time. You had no choice of the content, no choice of the time, of the scheduling. And the only thing you had was your TV. So what about now? Now you have your TV, you have your smartphones, you have your tablets. And with all the video on-demand services, you can watch pretty much everything you want, all the TV shows you want, at any time you want, everywhere you want, on any device. So that's really a new mode of consumption, and that really changed the way people are watching TV shows, and that enabled binge watching. So maybe you've already heard of binge watching because it really drew a lot of media coverage. And what those media and what the market research says about binge watching, it's watching multiple episodes of a television program in a single session. Okay, so that's cool. That's a really nice and simple definition, but it has some drawbacks. First, it completely ignores the context where you are. So basically, it doesn't depend on the TV show you're watching. It doesn't depend on the time you're watching it or anything. And this definition is only based on survey data. So they just ask people, okay, what do you think is binge watching? And in the end, different surveys got different answers. So someone say, okay, it's you watch 3 episodes and you're binge watching. Someone say, okay, it's you watch 2 episodes and you're binge watching. But we don't really know what is binge watching. There isn't really like a clear answer. So what exactly is binge watching? That's our question. We want to know, is there really a clear episode threshold? Or should we consider other important features to define binge watching? And another interesting thing is, are people really consistently binge watching, or is it just like an outlier behavior? So that's what we want to understand. To do that, we first have to define a model of viewing behavior. So first, we're going to take a step back from binge watching and really define a model of the viewing behavior in video on-demand services in general. And from that, then we're going to characterize what really binge watching is. Okay, so we do that using real-world data, real-world VOD data. So it's basically user interactions from 16 months of data from a US-based video on-demand service. It's a service that's available on TV, smartphones, and tablets, and it has pretty much all the famous TV shows you can think of. So let's start to model how people consume TV shows on that service. So basically, the goal we want to do is you start watching a session. We want to know the number of episodes that you're going to view. So let's take an example. It's Saturday. It's 4 a.m. And you start watching The Big Bang Theory on TV. What we want to know is what's the probability that you're going to watch 1, 2, 10 episodes. So what's the distribution? What's the probability distribution that you're going to watch a certain number of episodes? But maybe there are things that change. Maybe there are really different factors that influence your rate of consumption. So for example, if you watch 3 episodes of Game of Thrones, will it be the same thing as watching 3 episodes of The Big Bang Theory? That's a question. Another thing is, will it be the same thing to watch TV shows on TV or on a mobile device like your smartphone? Will it be different or will it be the same? The same thing for the time. Will it be the same to watch TV shows early in the morning or at night after work? Or also during the week or during the weekend? And another thing that might drive the way you consume TV shows is maybe you want to watch a lot of episodes, but maybe they're not available on the video on-demand platform. Maybe they're not released yet, so you might want to watch them, but you can't. So based on all of this, we define our model that's called censored Poisson regression with latent factors. So let's start. So we want to model the number of episodes viewed. And we assume that we have different types of viewing behavior. So that's the latent factors part. And basically, what we assume is that the number of episodes you view is a mixture of k different Poisson distributions. So basically, each of these distributions drives your way you consume with some rate that is lambda k. And all of these behaviors happen with some proportion. Those are the pi k variables here. And we formulate this as a maximum likelihood problem. So when you observe n independent sessions, the likelihood that you observe these n sessions is just that formula over there. Okay, so now the censored part. So like I said before, when you start watching a session, you watch 1 episode, 2, 3, 4, 5, and then maybe you want to watch a lot more, but you can't because either they're not available on your video on demand platform, or they're not released yet. But you still might want to watch more. So for that, we introduce a censorship threshold, which basically tells you when you start a session how many episodes do you have available to you. And that allows us to say, okay, so if the session is not censored, so that's the parenthesis on the left, then nothing changed. But if the session is censored, so if you reach that number of episodes HI, then you may have wanted to watch more episodes than that. So actually, we take that into account, and we don't take the probability that you watch just that number, but maybe you wanted to watch more than that. Okay, so finally, the Poisson regression part. So basically, we want to take the context of the session into account. So on what device you are, at what time of the day you are, and what content you're watching. All of this, we input it into the rate of consumption of the session. And basically, we use that formula. So basically, the rate of consumption is going to be dependent both on the covariates of the session. So these are the xi that takes into account the context, so device, time, and content. And on the coefficient of the component k, which is the behavior that drives you at that time. And basically, then the likelihood is just you just have to input. You have a new input that is the covariates of the session, and what we really want to know now is the coefficient of the component k. So now it's good. We have a nice formulation of the likelihood of our model, and we have as input the number of episode views for each user in each session, the censorship threshold, and the covariate, so the context of the session. And what we want to input is the coefficient of each behavior as well as their proportions. And that can be done using expectation maximization. All right. So how does it work? So are really all of these components interesting, the mixture, the censoring, and the covariates? So on the left here, it's the simplest model you can think of. So no mixture, no censoring, and no covariate. So basically just one single Poisson distribution with the same rates for all the sessions. And we see that in terms of likelihood of observing the session, it doesn't perform really good. But then when we add those components, the mixture, the censoring, and the covariates, we do better and better. And at the end, the last column on the right is our model, so with the mixture, the censoring, and the covariates, and we do much better. OK, so now we have a model. We want to know, does it work? Does it really fit the way people are consuming videos? So we want to do predictions. So we want to know you have a user. He's currently watching an episode, so he's in the middle of his session. And he already watched multiple number of episodes. We want to know, will he continue to watch the next one? So it's just a binary classification task. Will he stop or will he continue to watch the next episode? With our model, we can see that with a posterior distribution, and which we compared our model with different baselines, including logistic regression and SVM. And it turns out that our model can capture much more behavior of the user than those different baselines. So now it's cool. So we have a model. We know that we can predict things with it. So let's go back to binge watching. Now we want to really understand what is binge watching from that model. So what we identified is that the number of behaviors that drive your way of consuming is k equals 3 using cross-validation. And the first behavior, the first component, we call that regular behavior. So it's basically watching a little number of episodes. Then we have what we call binge watching, which is watching a larger number of episodes. But what we identified is that there is a third component, and that third component, we call that hyper binge watching. And basically, it's watching a crazy amount of episodes. Like, for example, the whole season in just one night. If people are laughing, I guess you do it sometimes. OK, so now we want to identify in which regime you are. So are you in a regular binge or hyper binge session? So with the model, we can use that using the mixture component. And we just say that the session is just the type of the most likely component assignment. So we see here on the left that all the regular session has a really low consumption rate. The binge watching has a much more, has bigger consumption rate. And the hyper binge can be really crazy, up to 25 episodes at once. OK, so with this nice definition of binge watching, we can now extract the context. So is it really the same thing to binge watch on TV and to binge watch on mobile devices? What we see here is that it's not the same. So What does that mean is that when you watch, to be binge watching on TV, in average, it means watching at least 3 episodes. But for mobile devices, it's much less. It's only 2 episodes. And for hyper binge watching, it's even, the difference is even clearer. That definition of binge watching is also aware of the content. So is it really the same thing to watch a comedy like How I Met Your Mother or a drama like Homeland? Well, actually, it's not, because the threshold of non-narrative comedies is much higher than narrative dramas. So if we see here for How I Met Your Mother and The Big Bang Theory, you have to watch, for How I Met Your Mother, you have to watch 5 episodes to be considered binge watching, but that's completely not the case for the dramas. For dramas like Homeland, you only watch 2 episodes and you're already considered binge watching. And the difference is even much clearer for hyper binge watching. Okay, so now we want to know, is binge watching really something consistent, or is it something that you do once and then you stop? So what we see here is just the transition frequencies from one type of session on the left to the other type on the top. So basically, what we see is that when you are currently binge watching, you have 30% of chance to binge watch your next session. But when you're currently in a regular session, you only have 16% of chance to binge watch your next session. So when you're currently binging, you're twice as likely to binge watch next. So binge watching seems to be kind of consistent, but still, the majority of the binge watching sessions are followed by a regular session. So that suggests that there is still kind of a TV hangover going on and that people are kind of sick of binge watching and then just watch a regular number of episodes. Okay, so that's all for the insights. So what did we do? So we introduced a new viewing behavior model that is general and takes into account the viewing context, a mixture of different behaviors, and the censoring of consumption. From that, we could extract a new definition of binge watching. And that definition allowed us to identify that, OK, there is a binge watching behavior. That's true. But there is also a hyper binge watching that is a third component that is really different than binge watching. And the nice thing with our model is that it's general enough so that we could potentially easily apply it to different areas, different applications. For example, you can think of binge eating or binge gambling. You could directly use the same data set for binge eating or binge gambling and apply that model like that to see what's happened. That would be really interesting. All right, that's all for me.
Thank you. Did you use any demographic data for users?
No. So we don't take into account the users. So we don't know who you are. We just know the context when you're watching and what you're watching. But we don't have anything that's related to you in particular.
But do you think that could be a future work for your
so if you have the data, yeah, that could be nice. But then that brings some privacy issues. So, yeah. But yeah, then that could be potentially something to look at.
Hi.
Hi.
In your training data, did you notice any large outliers? So I know sometimes if you're on Netflix and you've been watching your favorite show for a while, it might ask you if you're still there or if you've just left the room and it keeps going. So did you observe any sort of really far outlier behavior?
Yeah, so we have those, and those, I guess, get into the hyper binge watching part. So we know that
you're not sure if the person is still physically there.
Yeah, so we know that you're watching it, but we don't know if you're actively watching it or if you're just passively doing something else.
Or if you've gone to the other room,
yeah.
Right.
Did you actually analyze the time component of it? Like binge watching on a smartphone, the definition probably varies by the time, right? I mean, people probably do binge watching on TV a lot, but that's only probably during the night.
Yeah. So that's kind of embedded in the content, because basically every show's last a certain, like all the episodes have the same length. So the time is basically embedded in the content. Does that answer your question?
Meaning that.
So
not really.
So for example, for How I Met Your Mother, it was 5 episodes for binge watching. So that's 5 times 20 minutes. But for Homeland, it was 2 times 1 hour.
In the sense that during the daytime, let's say someone is traveling by train or something, right? So they have they're probably binge watching 2 episodes on a smartphone. So the chances of binge watching on a smartphone is probably higher during the daytime, and chances of binge watching on TV is higher during the night. So, and the definition of binge watching might vary depending on the time and the device.
Yeah,
as well,
yeah,
as well.
yeah. So I think we have a plot in the paper for that where we analyze really the difference for each of the features during the time during the day, but I don't have the numbers in my mind.
So maybe I missed something, but I just wonder, does your model assume the Poisson parameter for sessions from the same user correlate with each other? Do you assume that in the model?
For the same user?
Yeah, because like for one user you have multiple sessions, right?
Yeah, so we don't take anything about a particular user. We just have the context. So
it's just session.
Yeah, yeah. So when you come back, we don't know that you're the same user.
I see.
We just take the context into account.
Got it. Thank you.
So let's thank the speaker again.